Okay, this is chapter 9 from the book How to Prevent Dementia. Here's the book, and we're going to go through the effect of iron on increasing the risk of dementia. And, doctors don't know this stuff. Doctors don't know nutrition or toxicology. It's kind of funny. Like, I had a fourth-year medical student tag along with me recently, and I said to him, well, a couple of them, I said, here's the bad news is you've wasted the last 8 years of your life. The good news is hang around with me for an hour, you'll learn more than you did in the last 8 years. And then by the time the hour, they're usually with me a little while longer than that, but by the time that morning's over, they know they've learned more just from a couple hours of chatting, and that's why I laugh. I could train a health coach in just a week of watching these videos to know more about the common chronic diseases than a doctor learns through pre-med, med school, and residency. Because nutrition, epidemiology, and toxicology are what explain most diseases, and those things are not taught in medical school or residency. Okay, so anyways, we're going to learn about iron. So what's the deal with iron? Basically, iron, when it's free, this guy Eugene Weinberg has a good quote here. I'll show you his quote. Basically, iron is like fire. You want it in your fireplace to keep the house warm. You want it in the stove to cook, but you don't want it anywhere else. It causes problems anywhere else. And when I was a young guy, like a lot of young people, I thought iron made you strong, like Popeye. So I would always eat these Raisin Bran cereals with extra fortified iron. I thought that was a good thing. I didn't know any better. Other people, they'll eat red meat. They think they're getting a lot of good things in red meat to be strong. Okay, but anyways, what I learned later was you're just making yourself iron overloaded. All right, real quick, we'll go through how iron is metabolized by the body, and then we'll explain why it increases your risk of becoming demented. All right, so when you eat iron, it's absorbed in the duodenum, the first part of the small bowel, and it goes through these little doors here called ferroportin. Ferro means iron for ferrous, like rust in Latin, and portin, like portal, means door. So then they're taken up and transferrin. Transferrin are like a little wheelbarrow, or you can think of it as like a kayak with two seats to carry around 2 molecules of iron. And that travels the iron around in the blood and then delivers it to where it's needed. So lots of iron goes to the bone marrow where it can be used to make the hemoglobin molecule of red blood cells. So that's a common delivery spot for iron. Okay, red blood cells, once they're made, they typically live about 120 days, and then they're removed by the spleen. Normal capillary, normal red blood cells about 7 microns. That's worth knowing, that number. Normal capillary is about 5 microns. That's worth knowing too. And then the spleen capillaries are only about 3 microns. So when red blood cells get older, they get more stiff because their external surface is glycated. There's also something called the phospholipid phosphatidylserine. It externalizes from the inner leaflet to the outer leaflet of the plasma membrane of red blood cells. And anyways, they're so stiff they can no longer do the limbo, so to speak, getting through that tight capillary, and they become lysed. Okay, and then they get eaten by the macrophages in the spleen. So the spleen is like the graveyard for red blood cells, and a typical red blood cell lives about 120 days. All right, we talked about that too, how when a woman menstruates, she gets more young red blood cells coming out of her bone marrow where they're more flexible. And also because she menstruates, she lowers her hematocrit. That's why women live longer. They have a lower hematocrit, which lowers their blood pressure, and they got more young red blood cells, which are more flexible than a man does percentage-wise in their blood, which also lowers their blood pressure. Lower blood pressure means less intracranial atherosclerosis, and they live longer, and less coronary artery disease. Okay, hypertension is the number 1 risk factor for atherosclerosis and for stroke and for a lot of problems. Okay, so anyways, that's the scoop on the spleen. And then within cells, we have a way to store iron. We have these ferritin molecules, which are like buckyballs or like, Buckminster Fuller's geodesic dome. And they can bind, like one ferritin molecule can bind 4,500 molecules of iron. So you can store a lot of iron. And the liver is a very important location for storage of iron. Okay, and there's some iron overload diseases that are especially associated with excess iron in the liver. Okay, there's times when you want to decrease iron absorption into the body, and you can release this thing called hepcidin. So hepcidin comes from the liver, and it blocks the ferroportin door, so the iron that we ingest won't get in to our blood, and it'll just be defecated out of the body. Okay. Okay, the other nice thing about ferritin, and by the way, you want to ideally have your serum ferritin levels about 25 to 80. I made lots of lectures about iron. I made a whole series of hours and long lectures about all these details about iron. So if you're interested in that, you can watch those other lectures. In this video, we're just going to sort of talk about what's relevant to preventing dementia. And the other thing that's good about learning about iron is there's something you could do about it. There's something you could very easily do about it. Whenever I go to get a blood test, I always ask the blood draw person to take off a couple of tubes, and they do that for me. And so I don't like donating blood because they tend to take too much. You can do a half blood donation instead of a full unit donation, like half a unit donation. But make sure you're hydrated first. Otherwise, you can get lightheaded and you feel lousy. I don't like that. Or have somebody to drive you home, lay flat. But definitely be hydrated first. Wear a shirt that's easy to pull your sleeve up on. Okay, so anyways, I just like to have a little bit taken off each time I get blood labs drawn of any type. So anyways, the goal is to get serum ferritin down to about 25 to 80. They'll tell you normal somewhere in the ballpark of 300 or something. And I was told I was normal at 240, but I was kind of pissed off because I really want all my stuff ideal, not just normal. You know, normal in America just means you're as normal as the other fat, sick, stupid person. So anyways, I wanted to get it down to 25 to 80. Based on the best experts on the subject, that's where you want it to be, about 25 to 80. Some even say 25 to 50, but it's hard to titrate it that precisely. So anyways, I've been working mine down. I'm about 120 now after, you know, having some extra blood removed every time I go for blood labs over the last couple of years. 2 years, let's just leave it at, before I became more acutely aware of this issue. Okay, avoid meat because it's got tons of iron in it. Avoid high iron foods. They so-called enrich a lot of foods with iron, a lot of the grains and cereals. And that's a bad thing. You don't want that. If you have well water, make sure you have an iron filter to remove it. Don't ever eat off of iron cookware. Okay, next image here is going to show how do we deal with iron and why do we do it this way. If you think about an egg, in the center is the yolk where the baby chicken embryo grows, and then in the periphery is the egg white, you know, a lot of protein, if you will. But the eggshell is permeable, meaning that bacteria can get inside that eggshell. However, they can never get to the egg, and the question is, why can't they get to the egg? And the reason is the egg white has no iron in it. Bacteria need that iron in order to be able to replicate. So by sequestering iron, keeping it away from the egg white, that prevents bacteria from growing down to the yolk. All right? And it's kind of a similar concept of, and believe me, there's going to be a good reason why I'm going through this. It's kind of like, imagine you wanted to walk through 100 miles in the desert. You couldn't do it because there's no water. Just like you would need water to walk 100 miles in the desert, a bacteria needs iron to grow. And the relevance is bacteria get into our blood. They actually get into our blood far more often than people realize. And one of the ways we prevent them from growing is we sequester all our iron. Like I said, intracellular, we keep it bound up in those ferritin buckyballs, okay? And in our blood, we keep it bound up in transferrin. We don't want non-transferrin bound iron like I was just referring to. That's free iron. We don't want that. And so by keeping our iron all bound up, we prevent bacteria from proliferating in our blood, for example. And if we get bacteria in our blood and then we have a lot of free iron simultaneously, let's say a liver injury, those bacteria can be reactivated. This is also a reason why blood transfusion is quite overrated compared to what people thought of it about 30, 40 years ago. They realized, well, gee, we're having more problems with infections than we thought, because a lot of times there's bacteria in the blood. Okay, let's see. Okay, here's the next issue, like, who is iron overloaded? And the answer is, in a Western country, most of the men are. By the time they hit maturity, after 20 years of age, they're done growing, and then they just keep eating these high amounts of iron because they eat a lot of meat and they eat a bunch of iron fortified foods. And so that was made a rule, I don't know, around 1980 or so, that most of these grains and cereals and some other foods should be iron fortified. And that's a very bad thing because it makes men rapidly get iron overload. And then you get more. Iron's very prone to catalyzing oxidative stress. So we're going to talk about that in a moment, the fentin reaction, for example. And so it basically just creates more work for your tissues to do to sort of neutralize the oxidative stress effects of being overloaded with iron. So, you know, some people ask me about iron anemia, and I'm not that interested or expert on iron anemia. You know, that's more of, I think, of like when a girl, you know, she hits puberty, she starts menstruating, and she also starts growing rapidly. That's when a lot of females become iron deficient and have iron deficiency anemia. And that's sort of a separate topic. I'm talking about being iron overloaded, too much iron. All right. They used to call iron deficiency anemia the disease of virgins, you know, because they're menstruating and growing rapidly and they become iron deficient, especially where there's not that much food available. All right, well, anyways, women tend to become iron overloaded after menopause because they stop menstruating, okay, and they're still eating a Western diet. So it's basically just one more thing that accelerates disease, being iron overloaded, just because it's going to predispose to oxidative stress, and it's going to put more stress on the human body to kind of clear it. Okay. Oh, another thing I've seen is women who get hysterectomies, man, they have a lot more complications than is widely recognized. The Mayo Clinic did a study on 2,000 women with hysterectomies. They got much more congestive heart failure, coronary artery disease, a lot more strokes, early onset dementia. I've seen some very bad outcomes when women get hysterectomy at a young age, before 35 years of age. And the most common reason for it is fibroids, okay? Then the question is, well, why do they have fibroids? They have fibroids because they're not iron overloaded, they're estrogen overloaded. And that could be from all the estrogens in the tap water and their personal care products, from eating meat and how it changes the gut flora. So anyways, be aware of that. And I think it's also because a guy starts seeing his friends have problems, late 30s, early 40s. You know, so-and-so's impotent, so-and-so had a heart attack, so-and-so's going for open heart surgery. And so they go, oh, maybe I better get my act together if they have a brain in their head. Okay, so whenever I look at a brain and it's demented, and it's a female, demented, you know, earlier than expected, like let's say 50 to 65 years of age or something. First of all, I look for the obvious thing. Is she an alcoholic? Is she a drug addict? You know, things like that. And if it's not one of the obvious causes, then I make sure I look at her surgical history. And, you know, very often what I'll find in this context is she had a hysterectomy before 35 years of age. Okay. Because so basically, menstruation is why women live longer. It's what protects them from a Western diet. If you eat a healthy diet, it's not as big of an issue. Okay. Because it lowers their hematocrit, and they got more immature red blood cells coming out of the bone marrow. Okay, so here's just a quick picture of what basic foodstuffs are all about. Magnesium is located right in the center of chlorophyll. So you eat the plant, you eat the greens especially, you got your magnesium right there. So plants just sort of like do everything that's designed for us because it's our species-specific diet. On the other hand, with meat, you have the iron molecule in the center of a hemoglobin. Okay, so here's your heme, and that's because iron is a transitional metal, meaning that it has a variable valence, 2 plus to 3 plus. And because of that, it can be great in the center of an enzyme for handing off electrons, okay? And it's great in that it can sort of adjust its relationship to oxygen and facilitate reversible oxygen binding as part of hemoglobin for oxygen delivery. So that's all great. Okay, but here is the big problem with iron. This is why you want to lower your iron levels, right here. This is something you should know. The fentin reaction. And it's easy to remember. You remember Fe for fentin, for ferrous, that's the Latin word for iron, like for rust, and then Fe for fentin. And so in the fentin reaction, that facilitates, and there's also something called the Haber-Weiss reaction. Iron can become autocatalytic and cycle back and forth between Fe3 plus, Fe2 plus, Fe3 plus, Fe2 plus. And in so doing, start handing off electrons, like let's say to hydrogen peroxide, which is a common reactive oxygen species produced in mitochondria when you start leaking superoxide anions due to high-fat diet or other mitochondrial problems. And this will facilitate producing what are called hydroxyl radicals. And those can initiate lipid peroxidation chain reactions where they damage the intermitochondrial membrane, especially the PUFA fats in the intermitochondrial membrane, like the cardiolipin. I'll show you a picture of cardiolipin in just a moment. So the bottom line is excess iron is bad because the more excess you get, you start to overwhelm your body's capacity to store it, and then you get more free iron. And the free iron will, you know, when it gets a chance, become autocatalytic and produce these free radicals, molecules with an unpaired electron in their outer orbitals. They're also called reactive oxygen species, and these can be very damaging and initiate chain reactions that destroy like intermitochondrial membrane and other tissues. They'll destroy DNA as well. They can destroy proteins. Okay, so this is called ferrous redox cycling. That's a very important thing to know, ferrous redox cycling. There's even an entire category of cell death called ferroptosis related to excessive free iron and it undergoing, helping to cause lipid peroxidation, all right? So this does come up. It's a smart move to keep your serum ferritin lower. Because a lot of people say, oh, you know, they've got some type of problem, whatever it might be. And they're like, I wish I could get better. Like maybe they're trying to get better from cancer. Maybe they're trying to get better from just heart disease, diabetes, whatever. What I would say is try to optimize everything. Get your serum ferritin down where it should be. I can tell you, I've talked with Gregory Sloop. He's the best atherosclerosis researcher in the world. And he told me, yeah, he donates blood routinely because he wants to, lower his hematocrit and get these iron. Well, mostly he does it to lower his hematocrit, but he's also doing this. And we talked about this too. He's not as up on oxidative stress. He's not as interested in his iron, but he does it to lower his hematocrit. So I'll go as far as to say that. I do mine because I want to lower my serum ferritin. I'm not as worried about my hematocrit. Okay, like I said, a typical American adult man, postmenopausal woman is iron overloaded. Okay. And, everybody, there's a lot of people are big fans of supplementing PUFAs like omega-3s. I personally think that is totally overrated. I don't recommend it. Okay, because the more double bonds you got in these PUFAs, you got a lot of double bonds. That's what, unsaturated means. The more vulnerable they are to lipid peroxidation. Okay. That's why they store them in the fridge in an opaque bottle. Okay, and then you're going to put them in your body at that hot temperature. Okay, anyway, so here's what's happening in the intermitochondrial membrane. These CLs stand for cardiolipins, and notice the four fatty acid tails. They're much more vulnerable to lipid peroxidation. All right, so you've got a situation, let's say the mitochondria is being inhibited by some excessive dietary fat, especially saturated fat. You start leaking more electrons, let's say from coenzyme Q down to the oxygen in the mitochondrial matrix, and it produces superoxide anions. Again, these are free radicals, unpaired electron in the outer orbital. And these can then also, if there's a lot of nitric oxide around in the mitochondria, they can form peroxynitrite, and that is very much capable of initiating toxic reactions and lipid peroxidation itself. That kind of gets into a whole other stop. We're going to get into that whole, this is called the no pathway. We're going to talk about that later. We're building up to that. What I'm doing is I'm giving you the knowledge, the foundation to understand the more advanced topics, okay? And basically for oxidative stress, you don't need to know all the details. All you need to know is if you've got more oxidants than you've got antioxidants, you're in trouble and you're predisposed to oxidizing things. That's oxidative stress. When oxidation is greater than antioxidation, so to speak. So this superoxide anion would be an oxidant. And that's very common. See, what happens is it wants to get an electron to create an octet, 8 electrons in its outer orbital, for example, because that will help it to be at a stable state. Whereas what the antioxidant does is it gives an electron to these oxidant molecules, but the antioxidant typically is such a big molecule that it can remain stable despite giving away an electron. So superoxide dismutase is an antioxidant enzyme. Vitamin C would be an antioxidant molecule, for example. Okay. All right, so what I'm saying is, in this context, if you've got a lot of superoxide anions and then you got free iron around, it'll grab some of this hydrogen peroxide before these other enzymes, catalase or glutathione peroxidase, can get to it to neutralize it into water, and it will instead produce hydroxyl radicals, which can then cause lipid peroxidation and damage the mitochondrial membrane and destroy the mitochondria, cause it to die. Okay, and mitochondria are a big deal. They're where energy comes from. And that was the word I mentioned earlier, ferroptosis, sort of a type of cell death related to excess free iron and its risk of lipid peroxidation. So here is a cardiolipin, and it's got multiple double bonds. And the more double bonds you've got, the more vulnerable the molecule is to lipid peroxidation. Okay, and so if you're producing a lot of these hydroxyl radicals due to having free iron in your mitochondria while you're simultaneously eating a lot of dietary fat, especially sat fat, and you're leaking all these electrons to form superoxide anions and then subsequently the fentin reaction, these are very vulnerable to being damaged by that. Okay, and this will cause lipid peroxidation chain reactions, trash these double bonds, and then the chain reaction continues because each one becomes a free radical itself and then wants another electron, okay? So like when one free radical reacts with another one, it'll typically steal an electron from them, then they become a free radical. It's almost like a zombie bite turns them into a zombie or a vampire or whatever you want to call it, and then they, react with the thing next to them, and likewise it continues on and does a lot of damage to the molecules as it happens. Oh, and that's all I've got for iron. So What were the key points on this talk about iron? I would say that ideally, you'd like your serum ferritin about 25 to 80. I got several lectures where I go through all the papers of why that is. I go through all the books I read about iron and stuff, and I go through all the Douglas Kellogg, Theresia Praetoria stuff. If you want to hear that, I got lots of lectures on all this stuff. But the bottom line for anybody is you want your serum ferritin kind of on the low side, at least below 100, because it'll just reduce your vulnerability to oxidative stress, okay? And again, I'm a big believer in just maintaining optimal overall health, healthy diet, lifestyle, sleep, stress reduction, sense of purpose, and all these things, because it just protects you from everything. You know what I mean? It's kind of like when you become a good student, you're good at every subject in school. And it's also like when you optimize all these parameters of your health, you improve everything, your physical strength, your energy, your clearness of thought, etc. So anyways, that's the scoop on iron. Hope that's helpful.